Okay, so in this example, we're talking about a cone. Okay, so I'm going to sketch my cone out, and it has a cone angle of 36 degrees, so maybe something that looks like that. And the cone angle is 36 degrees. Okay, so I'm going to write my 36 degrees in there. Okay, and it says the cone has a height of 10 centimeters. So I've described the shape of this in terms of the angle. I do have one side length, but I don't have a ratio here. So that's 10 centimeters to the center. So if I imagine my cone in there, there's the center of the cone. That line is 10 centimeters long. And we need to figure out the radius, r. Okay, and we also being asked to find the slant height, which it will call s here. Okay, often this is given to us as L in a lot of formulas. So to do that, I need to use that right triangle. So I'm just going to highlight this right triangle here. I need to use this right triangle here. But to do that, I need the angle inside here, which is not 36 degrees because I split that 36 degrees in half. So that angle is 18 degrees. So that's the angle that I need to work with. So to do this problem, I do need to know that angle there. I have an angle, I have a side length, and I have an unknown side length that I'm solving for. So basically, if I kind of redraw this triangle here, I have 18 degrees. I want to solve for r. I want to find s as well, but I've been given the 10 centimeters adjacent side to that angle. Well, if I'm going to solve for r first, I'm going to use the opposite and adjacent side, that's tan. So what I can then set up is a proportional equation using the tan ratio. So tan of 18 degrees is equal to r over 10. And then from my calculator, I can get tan of 18 degrees. So this is not a special angle, so I need my calculator. I'm going to use 3 decimals, and it's going to be 0.325 to 1 is equal to r over 10. I'm just going to solve for r, and r works out to be 3.25 centimeters. And that looks about right based on the diagram. I can do the same thing to solve for my slant height. To solve for my slant height, I'm going to involve, in this case, I'm going to use adjacent and the hypotenuse. So I'm going to use cosine. So I'm going to say that cosine of the 18 degrees that I know is equal to the adjacent 10 over the hypotenuse s. Okay, so once I've set up that ratio, I can work out cosine 18 from my calculator. Again, I need a calculator for this because it is not a special angle. So I get 0.951 to 1. That ratio is equal to 10 to s. S is what I'm solving for. I can cross multiply this, and I'm going to get s is equal to 10 divided by 0.951. So solving for s, 10 divided by 9.951 gives me 10.51 centimeters. Okay, so that's going to be 10.51 centimeters is going to be the length of that hypotenuse. It's not going to be very long. It's just going to be a little bit longer than the adjacent side. So that's the slant height and the radius. I've got the radius. I'm just going to make sure that the radius is what I've solved for in blue here, and the slant height is what I've solved for in red over here. For example 3, we're being asked to find the ratio to 3 decimal places, and all of these are not special angles. So I'm going to be using my calculator. Again, I need to go from angle to ratio, so I'm going to use sine, cos, and tan to do that. So I'm just going to type this into my calculator. So sine 23 equals 0.3907, so I'm going to round that to 391, and what's implied is being compared to 1. Cos 76 degrees, for my calculator again, is 0.2419, so I'm going to round that to 242, and again, what's implied is that it's being compared to 1. My slope of 34 degrees, or the tan of 34 degrees, is going to be 0.6745, so I'm going to round that to 5 to 1. Okay, so what this means then is, if I compare the opposite and hypotenuse, I'm going to get a picture that looks like this. 0.391 to 1, and that angle relates to the 23 degrees. What this tells me over here is that the adjacent to hypotenuse is 0.247242, so the hypotenuse is 1. That's about a quarter of the length. Okay, and that's going to give me a 76-degree angle. So those are supposed to go together. A slope of rise to run. So if I have a rise and run of 0.674, just kind of squeezing that in there. Maybe I'll just do that properly. .674, so 67% of the run is a rise. That's going to relate to a 34-degree angle. That's what my calculator is essentially giving me when I type these things into my calculator.